Alright, hello and welcome to your next lab. This one is a long one, so I'm going to give you normally 2 weeks, but because of the midterm I'm going to give you 3 weeks to do this lab, so please start early. And it's going to be about BSTs with a Pokemon twist. So get the starter code as usual. The only thing that you will be turning in is this bst.cpp. I've made all the tests in bsttests.cpp, and all you have to do is implement all of the methods that are unimplemented inside of bst.cpp and declare it in bst.h. So there will be a BST class, it'll have a Pokemon theme, so every node will store inside of it not just random ints and strings and stuff, but things of type Pokemon, which I'll show you. And instead of like insert, at least for the public methods, I'll say catch. And instead of remove, we'll say release. Okay? So that's the idea there. Pretty short instructions, it's just going to be a lot of coding. Okay? So let me show you what you're working with. So in bst.h, this is where all the things have been declared. Here's the type of things that you'll be storing inside of your BST. So when you catch a Pokemon, you insert it to your empty BST. It starts out empty with the default constructor. You're going to insert it, and each BST node, here's the structure for that, will have left, right, parent as usual, but a key and a separate value, and I'll call that value data. Okay, so the key will be the number of the Pokemon that you're inserting. That's how you order them. And then the data will be the entire Pokemon itself. So when you go and insert one of these, you'll extract the number and use that as the key for the new node that you make, and the data will be the entire thing itself. Okay, just copied into the node now. So that shouldn't be too bad. Several helper functions, you'll be implementing quite a few of them, especially remove. That'll probably take the most of your time. Okay, remove and predecessor. Okay, so your one member variable is a pointer to your root, and then you go and implement all this stuff in bst.cpp. So, for example, I've done all this for you, but you're going to start implementing the constructor. You're going to implement the catch Pokemon method, which will insert into the tree. By the way, for the constructor, you just have to make the tree empty. Right now, that's not being done. Search you need to implement. Return a pointer to the node. This is a private member function, so this will be used by the search for Pokemon method, which I have already gotten implemented for you. So all you have to do is implement the search function to actually go and search the tree for the node itself with a given key. I've done the in-order traversal for you. Then you'll need to start working on the removal functionality. So the first thing is the predecessor function. So instead of successor, I'm having you do it with the predecessor for that special case of the remove method, where you have 2 children and you have to remove a node with 2 children. Then you have the release Pokemon method, which actually implements the high-level version of removal. It's going to essentially search to find the node that you want to delete if it's there, and if so, you call this remove method, which is a private, there we go. It's a private method that the user doesn't get to call. You're calling it for them. Okay, that's like the lower level thing. So remove will take a pointer to a node in the tree and then remove it by deleting it. So if it's a leaf, get rid of it. If it has 1 child, if it has 2 children, you're going to have to implement all of those cases. Okay? And then the final thing is a method that I have implemented for you. It's very long, and hopefully it works. Please yell at me if it does not. But what it does is it makes a textual form of your tree at a given moment. So you can say your tree, your BST object, .toGraphviz, and then you can go and take this to webgraphviz.com and paste it in there, and it will draw the tree for you, which is really nice. So I'm going to show you that in just a second. So I think that's everything I wanted to talk about. Yeah, you're just going to implement bst.cpp, and that will be the one thing that you submit. All the tests are there for you here in bsttests.cpp. And yeah, so I'm just going to insert some Pokemon into your BSTs, search for all of them, make sure that all that's working. And then I'm going to test lots of removals, and then watch your tree change to eventually become empty. Okay, so that's the idea there, and you're going to have a lot of issues. Okay, it's just a fact of life. You are going to have a lot of seg faults probably. You're going to have weird bugs that happen. It's one of those labs. So I'm going to teach you some extra tips for using GDB right now. The first thing that will come in handy quite a bit is this concept called breakpoints. So maybe if you've used like Visual Studio, the big one, you might be familiar with this already, but it's very useful if you've never heard of it. So GDB, normally, like when there are no runtime errors, it will run your program to completion. So it'll just stop executing, even if you failed some tests. As long as there's no runtime error, if there's just a bug, it's not going to stop your program. You can have it stop if you include a breakpoint. You can tell it to break on a given line of a given file. Okay? So it'll stop right before line 46 if you give this command, break bsttest.cpp line 46. It'll set a breakpoint on line 46. And when you run the program, it'll stop there and wait. So what I'm going to do is let me go to the tests file. Let's pick a nice line. I don't know. Let's pick line right before we release Pikachu. So line 99. Let's change it to that. We're going to break on line 99. And I'm going to go to my solution right now. So gdb / pretend you're running it, bst tests, and okay, we say break to set a breakpoint. Boop. bsttest.cpp line 99. Hit enter, and it says, okay, we made a breakpoint for you. We're going to stop there when you run this program. So now if you say run, it'll start the program and it won't complete it, even if it executes normally. It'll start it and then stop it right before it executes this line 99, which is a nice place. Maybe you're worried about your output around that area. So that's a really nice place to stop usually. Just pick a line and make a breakpoint for that line. Okay? So then you can do things as normal. You can see your stack, you can see the values of your variables, you can print stuff, whatever's in in scope at this time. So I got a vector, I've got a BSTB, and you can tell it to do stuff. You can print out the result of calling your functions, but this all looks weird when you're printing strings. And so one thing that you can do is, instead of say print, you can say call puts, and then put the thing that gives a string in between. And I'm going to show you that on the next slide, so don't worry. Because, see, that makes it look better. You say call, and then put a string on the screen, please, and then you give it the string. Okay, so that's the idea. Now I want to show you that method that I've implemented for you. Use toGraphviz to actually let me go to between. I forgot this one, but maybe the order is a bit off. Okay, so when you're in GDB at this point, your program hasn't crashed, so it can still run. Okay? Maybe I should say that. Your program hasn't crashed. Or if you use the breakpoint. You can keep running it line by line. You can tell GDB, hey, next. Execute the next line of code, wherever you are. List shows you where you are. I'm on line 99 and about to execute it. So I can say next to step over that function and actually go and execute it. You can also use step to go into the functions. Okay, so you can say step, because right now it's about to execute assert equals, and maybe you want to know how it's working. You can say step, and it's going to do the first thing, which is not in your code anymore. It might go into functions. Next just goes over them and executes the entire line. Step, step, next. Things like that. Okay? So, I guess that's what I wanted to show you. You can now print other stuff. You can print the values of variables. Now, after things have changed, you can call these methods. And then the last thing that I want to show you is how to actually make a graphical version of your stuff. So call this toGraphViz method. You can always put it in your program, just add it to the test and get rid of it before you submit, or you can call it from GDB. And we just noticed that the print doesn't actually work. So you say call puts b.toGraphViz, assuming b is the name of your tree, and this is what my method does. It makes this stuff, and I want you to paste everything in between these lines into this website. Okay? I'm going to copy and paste all of this, and it's going to show you your current tree at the moment, and this should help you debug. Okay? I worked very hard on this. And so we're going to go to that website, webgraphviz.com, and we're going to paste in what we got back. And we'll hit generate graph. And oh man, does it show you the current tree at the moment. And you can use this to test whether or not you're doing things in the proper order, whether the tree looks as it should, like, yeah, 3 is bigger than 2, so it has to be on the right. That all makes sense. These little tiny dots are null pointers, and I've tried to label the root, and it should usually go to the top. You don't really have a lot of control over this viewer, but I think it'll usually go to the top. Yeah, I hope that that is all useful. This is a pretty complicated lab. Okay? Oops. So please get started early. Yell at me if you have any questions. Use this new GDB stuff. It will save your life. And I think that's all I have to say. Good luck.